All right, Algebra 1B students. Welcome to part 2 of lesson 12-2 on creating histograms. Today we're going to take those frequency tables that we were making in our last video, not the cumulative frequency, but just our regular frequency tables, and we're going to turn them into something called a histogram. Okay, now a histogram is a graph that displays data from a frequency table. Okay, it shows intervals of data points, and then it shows the frequency of each of those intervals on a graph. Okay, so a histogram has one bar for each interval, so it's going to look kind of like a bar graph, but they are actually different things. The height of the bar, a height is what shows the frequency of the data points in that interval. Okay. All of the bars touch, there are no gaps, and we should always make them equal width. Always. So, as we were doing before, when we create our frequency tables, we want to make sure our intervals are always the same width, okay? For example, here's a problem that shows the number of hours per week that a group of students spend watching television, okay? In a week, in 7 days, this is the number of hours that kids spend watching TV. And they want us to make a histogram to represent this data. Okay? The first thing that we do then is to create a frequency table, just like we did in our last video. So we set our intervals, and in this case we decided to count up by fives, well really by sixes I guess. We take 0 to 5, 6 to 11, 12 to 17, 18 to 23 as our intervals. And we just went through and found all of the data points that were in the first interval, 1, 2, 3, 4, 5, 6 of them. And then the second interval, 1, 2, 3, 4, 5 of those. Then the third interval, 1, 2, 3 of those, and 1 in the last interval. Okay? So now we take that information from the frequency table and we translate it to a graph. Okay, we translate it to a graph in the XY direction. So there's Y going up, there's X going to the right. Okay. And then along the bottom is always our intervals. Intervals are always along the X-axis. Okay? And then our frequencies obviously go up the y-axis here, 1, 2, 3, 4, 5, 6, and so on. Okay? Now, in the interval between 0 and 5, that would be basically from the y-axis up until this line here, we know that there are 6 data points. So I make a rectangle that goes straight up from that right endpoint at 5 all the way up till I get to 6, and then I go straight over. Okay? And here is my first histogram bar. From 0 to 5, it shows a frequency of 6. Okay? Then, just to the right of that, between 6 and 11, I'm going to go straight up from 11 all the way until I get to 5, because my frequency there is 5. So here's my second histogram bar between 6 and 11. Okay, and I'll do the same thing then for 12 to 17. I'll go up to 17 and go up from there until I hit 3. 1, 2, 3 right there. And then I'll do the same thing for 18 to 23, but I will only go up until I get 1. Up to 1 and over. Okay, so here are my 4 intervals. And I have a bar for each interval that shows the frequency for that interval. Because obviously there's more on the left than there are on the right. More in the first one than the last one, clearly. So this histogram just sort of turns my frequency table into a graph with bars for each interval that show the frequency of that interval. Okay? We're also going to have practice problems about describing the shape of an interval. So there are 3 different shapes that I need you to be familiar with at this point. The first is called uniform. if you have frequencies that are almost all the same across your bars, now these are not quite perfect, but they're relatively close to being right at that same level, roughly the same height is the key word there, roughly the same height. We say that that histogram is uniform. Uniform, meaning it's uniform across all of our intervals. They all have a uniform or the same frequency. Okay? If a vertical line can divide a histogram into two parts that are close to being mirror images of each other, meaning if it can divide it pretty much in half through the highest peak in the middle, then the histogram is called symmetric. So here, we have our highest peak right here in the middle, and the two halves are pretty much mirror images of each other, very, very close. So because of that, because we can kind of divide it in half straight down the middle, we call that histogram symmetric. Okay? And then if the histogram has a very high point, but that's not in the center, then that histogram is called skewed. Okay, so obviously here's our high point, but there's much more stuff to the left than there is just a little bit to the right. Okay, so more to the left than there is to the right. That's called skewed. It's kind of off center. Okay, so you'll also see problems in your practice problem set that say something like this: is each histogram uniform, symmetric, or skewed? Okay. Now, here in letter A, I think it's obvious that it's not uniform because these two bars are much lower than the other three. And I think this peak, this high point here is straight down the center. So I would call this one symmetric. Definitely a symmetric. Okay. This one in letter B, again, I see one bar that's much higher than another, so I would not call this uniform. This highest point right here is obviously farther to the right than to the left. There's a lot more over here than there is over here. So this one would be called skewed. Okay, so those are the things that I'm going to ask you to do in your practice problem set today. That is, create histograms and tell me if they are uniform, symmetric, or skewed. If you have questions about any of that, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you for right now. Have a wonderful night.